how many valence electrons sodium has. So we're going to go ahead and find sodium on the periodic table of elements, or I will tell you what row sodium belongs to. So just to highlight that this is a row, that's the first row actually of the periodic table of elements. Hydrogen and helium belong in that row. This is the second row, this is the third row, and so forth and so forth. Another term is called shell. This is the first shell, or the first row. This is the second shell. I'll point out what a shell is right now, and this is the third shell. And I'm going to stop at the third shell because that is where my sodium is found, on the third shell. I don't need to go any higher than that shell. A shell is basically where the electron is going to orbit, where a specific electron is going to orbit, because sodium actually has more than one electron, which I'm going to show you how we're going to find out right now. So a shell is the orbit, the circle, if you will, around the nucleus of the sodium atom. So I'm going to go ahead and draw that. It ended at the third shell, so I'm going to go ahead and draw 3 rings around a sodium atom to start us off. So I'll draw it over here. I'm going to put Na, the symbol in the middle. You can also do this as just, well, let me go back, a circle. That's fine too. The nucleus, you don't have to color it in. Maybe you just want to do a dot. That's fine. I like to draw the symbol, and that's telling me that that's the nucleus, or the center of the atom. Now remember, it's in the third shell. So I'm going to draw 1 shell. That's 1 circle around the nucleus. My second shell, that's number 2, and my third shell, 3, around the nucleus of that sodium atom. And I'm going to stop there. I don't need to draw any more rings because, as I saw, sodium was in the third row of the periodic table of elements, or it has 3 shells. Okay, now I'm going to use this concept down here, in that each shell of an atom will hold a maximum number of electrons. So I can actually see that the first shell can only hold 2 electrons. I have a 1 in parentheses. I'm telling you that that's the shell number. Well, the first shell can only hold 2 electrons. Yeah, let me leave that. So this is my first shell right here, the one that's closest to the nucleus. I'll start with that one. That's shell number 1. I don't start at the outside one. Never start at the outside one. That's a different shell. The first shell is the one closest to the nucleus. And again, it holds only 2 maximum number of electrons. So I'm going to go ahead and draw 1 electron here and 1 electron here. And I stop at 2. It didn't matter where exactly you drew them. If you wanted to draw them like that, that's fine too. What I do want you to appreciate is that I've drawn them opposite to each other, and they will be found opposite to each other. You won't see this in a well-behaved atom in real life. Electrons like to stay far away from each other because they have similar charges. That's just how they behave. Okay, so that's 2. So I'm going to go ahead and write over here a concept. And the concept that I want you to appreciate now is that sodium actually has an atomic number of 11. Let me actually zoom out because I got rid of that. 11. I can see that number here. I've taught you that the atomic number, that's 11, I've taught you that the atomic number is the number of protons, and it is. That doesn't change. But what an atomic number also tells you is the number of electrons. Total electrons, number of total electrons in the atom. So I'm going to actually use that number, 11, right here. And so far, I've drawn 2 in the first shell. It gave me 2 electrons. I'm going to subtract 11 from 2. And that's going to give me 9. I still have 9 electrons that I need to place in the other shells for my sodium atom. Let's go ahead and revisit that diagram. My next shell, my second shell, tells me that 8 electrons can go in there, and only 8. I have 8 more electrons to write since I have 9 overall. Let me go ahead and fill in the second shell with 8 electrons. That's 1, 2, 3, 4, 5, 6, 7, 8. There are those guys. They're happy little spots in the second shell. I am not going to do any more than 8 electrons because that is the maximum number that the second shell likes to hold. There's no more space for no more guys, only those 8. I go ahead and do some math here. Consider my second shell held 8 electrons. I did have 8 electrons to give for the sodium atom to put in the second shell. 9 subtract to 8, I have 1 more electron remaining. That guy needs a spot right here. And as you guessed, he's probably going to go in the third shell, that last shell. I want you guys to see that that third shell could hold 18 electrons. That shell is massive and has a lot of space for a lot of electrons. 18 of them can actually fit in the third shell. But I only have 1 more electron left. So I'm not going to draw all 18 electrons. I'm only going to finish off by placing that last electron in the third shell. So I'm going to go ahead and do that. It doesn't matter where you draw it. You want to draw that guy there? Go for it. You want to draw that guy there? Go for it. He's alone in that third shell. And since that is the outermost shell of my atom, the outermost, the shell that's located the furthest from the nucleus, the outermost shell, it holds what is known as, that special little guy, a valence electron. Those guys are electrons found in the outermost shell. Sodium has 1 valence electron. I'll go ahead and finish my math just to show you the third shell had 1 electron. No more electrons to give. This is how you find valence. There's also a neat little shortcut that I'll let you guys figure out for your own as well. I want to teach you this way so that you can appreciate what electron shells are and how we arrive at valence electrons.